Okay. Okay. Good morning, all of you.
Good morning, sir.
Yes. Am I audible?
Yes, sir.
Okay. Okay. So let's start. So we have completed in our last classes this our CT and PT. Okay. And the next part in this module, that is module 4, you know that this is the transducer part. So today we will discuss about the transducer. Okay. So first of all, you have to know what is transducer. Anyone is idea what is transducer?
Sir, that
Anyone please tell
converts
me
one
what is
energy
transducer? Yes.
form to another form.
Yes. Yes. Very good. Very good. So you know that the transducer, it is basically one of the device. It is uses in our electrical purpose, and it is also uses mechanical device, and it is also uses in our electronics appliances. Okay. So this transducer, it is a device which is convert, it is energy, it is another form. That is, energy is transformed one to another form. So this device, it is called the transducer. Okay. So this transducer, it is basically uses in our mechanical purpose, electrical purpose, and also electronics purpose. So this is the basic what is a transducer. So just wait, I am sharing my whiteboard, then we will discuss. My whiteboard is visible.
Yes, sir.
Okay. So first of all, you have to know transducer. So transducer, it is basically one of the device. So it is a device which is convert energy from one to another form. So this device, it is basically called the transducer. So in our mechanical purpose and also electrical purpose and electronics purpose, this transducer we have to use different categories or different resistors. So now you have to know. So what is the purpose of uses these different types of transducer? Okay, so this is the application area. Application area of transducer. So when you have to go the measure of current, voltage, resistance, so there are lots of application area are available for the transducer. So I am written one by one, so please note down it. So first of all, current, voltage, resistance, inductance, capacitance, frequency, phase angle, power, magnetic flux, okay, flux density, flux density, reluctance, acceleration, density, displacement, flow rate, then force, pressure, temperature, altitude, speed, okay, liquid level, light intensity, etc. So you can see, so this transducer, basically it is a device which is convert energy from one form to another form. That means I am giving you one example, a small example. So your temperature, your human body temperature, you have to know it is measured by the thermometer. Okay. So using this thermometer, you know that you have to easily measure the human body temperature. So when you have to see in this temperature, so this temperature either it is also high or it is also low. So using this meter, you have to easily measure any hot body temperature or cold body temperature. So this temperature measurement, it is basically used by a device, and this device it is called the transducer. Is it clear or not? Please respond everyone. Is it clear? Am I audible?
Yes, sir.
Yes, sir.
Okay, so please respond everyone. So then I am understand you have understand or not. So here you can see these are the basic application area of the transducer. This is the current measurement, voltage measurement, resistance measurement, inductance, capacitance, frequency, phase angle, power, magnetic flux. This is a magnetic flux, flux density, reluctance, accelerations, density, displacement, flow measurement, pressure measurement, force measurement, temperature, altitude, speed measurement, okay, liquid level measurement, light intensity. So these are the basic area for measurement of using these different types of transducer. So in your syllabus, there are lots of transducers available. That is temperature sensors, RTD, thermistor, and also LVDT, strain gauge, piezoelectric transducer. There are lots of transducer we have to read in this module. So when you have to go the next, now you have to read the fourth semester, and then when you have to go the next year, that is third year, one of subject is present, that is process instrumentation and control. And this process instrumentation and control, it is very important for your electrical engineering, because when you have to go the practical working in a field that is your industry oriented, so in that case, there are lots of measurement device you have to use in practical field. That is temperature measurement, force measurement, okay, pressure measurement, liquid level measurement. So this is basically very important for this transducer part. Okay. So now, so in our classifications, that is in our application area, we have to classify this transducer into different categories. So next question is classification of transducer. So first of all, this transducer, it is classified first one, primary and secondary. Primary and secondary transducer. Number two, active and passive transducer. This classification, it is very important for your exam purpose. It is also coming in your exam questions also. So passive transducer. Number third, this is analog and digital transducer. And number four, this is the transducer and inverse transducer. Inverse transducer. Sorry, DUCER. Spelling and mistakes. Transducer. Okay, so these are the basic classification of the different types of transducer. First, primary and secondary transducer. Number two, active and passive transducer. Number third, analog and digital transducer. And number four, transducer and inverse transducer. So these are the basic category or basic classifications of the active and different types of transducers. Okay, so using this different application oriented, we have to classify these primary and secondary transducer. Now you have to know, so in our practical oriented, there are different types of transducer we have to use this. So in your syllabus, there are temperature, pressure, displacement, humidity, fluid flow speed. These are basically coming in our electrical transducers. Okay, so this transducer, it is basically defined as the device which is converts energy or any types of information from one form to the another. So I have given you one example, that is a thermometer, mercury thermometers. You know that. So this mercury thermometer, it is a temperature measurement device. So using this mercury thermometer, you have to easily measure one hot body temperature as well as also cold body temperature. So here you can see this temperature, it is basically first measured using this mercury, then this is converted into the one displacement. That means the one area or length, because you know that when a clinical thermometer you have to see, it is uses for the human measure for the human body temperature. One mercury bulb is present in the lower part of the thermometer, and this glass thermometer, it is labeled by a scale. Okay, so this scale, using this scale, there are some measurement are present. That is either it is degree Celsius or Fahrenheit. You know that. So these scales, we have to see in particular the temperature is present for the particular measurement. Okay, so using this scale, that means the one displacement is present. That means the one length is present. So this length, it is up or down. So using this scale, you have to tell the human body temperature is 98.5 degree Fahrenheit or degree Celsius. Okay, so you know that. So these are the basically particular parameter for the temperature measurement. We have to use this mercury thermometer. Okay, so there are lots of transducer we have to measure. I'm written here. Next, particular area we have to measure, that is a mechanical, electrical, magnetic, Okay. Sometimes it is also measure optical purpose, chemical, chemical transducer, chemical sensors. Okay. Chemical. Sometimes it is also acoustic. That means the sound measurement. Okay. I am given one example one by one. Then thermal, nuclear, etc. So these are the basic area. Okay, these are the basic area for measurement of the different application of the transducer field. That means mechanical. You know that when you have to go the different types of valve or gauge, okay, valve system. That means the liquid level valve or any types of air valve. So in your when you have to go the different types of industries where the production unit, so there are lots of valve characteristics we have to see. So these are the basically mechanical transducers as well as also electrical transducer. Okay, so electrical transducer we have to use different displacement measurement, different flow measurement, different temperature measurement, different accelerations. These are the basically categories of the electrical transducer. Then magnetic transducer. So when you have to use this in magnetic field, okay, magnetic field generation unit. So this is basically classified into the magnetic transducer. Optical means that is a light energy. You know that. So when any light energy it is converted one form to the another form. So this device it is a category in under optical transducers also. Chemical transducer, you know that this chemical transducer it is uses different chemical industries. Okay, so using this chemical transducer you have to easily measure a particular composition, particular temperature of the different types of liquid, because you know that in our chemical industries there are lots of acid, lots of base, that is a third we have to use it because it is harmful for our human body or human environment. So using this chemical transducer, you have to easily measure the particular temperature or humidity, or as well as also different parameters using this chemical transducer. Then acoustic, you know that acoustics means that is a sound which is related to our sound. Okay, so when you have to use this in home theater or microphone, this is a easily examples. You know that these microphones, when you have to any tell or any singing a song using this microphone it is converted your voice signals into the electrical signals. Then these electrical signals you have to hear from the sound box or any sound theater also. Okay, so this microphone it is basically here work as a transducer. This is called the acoustic system or acoustic transducer. Is it okay? Is it okay?
Yes, sir.
Okay, sir.
Yes, sir.
Okay, thank you. So next is a thermal. You know that thermal that is a basically when you have to go a thermal power plant. So in this thermal power plant, you know that there are lots huge amount of temperature it is arise in our boiler part. So when you have to measure the temperature in the boiler part, there are the increase in temperature is level is 1200 degrees Celsius or more than 1200 degrees Celsius. So how it is measured? So using the different types of temperature sensor or transducer, that is pyrometer, that is thermocouple, thermistor. So these are the basically measure for the high temperature in our thermal transducers. Okay. Then nuclear. This is the nuclear power plant. You know that in our nuclear power plant there are temperature. It is a huge amount of temperature. It is arise. So using this nuclear power plant, there are different types of nuclear transducer available. So this is basically classified into our nuclear. So these are the basic uh, application oriented transducers classifications. Is it clear? Now, So in your syllabus, basically electrical transducer, it is available in your measurement and instrumentation syllabus now. So now you have to know the electrical transducer. So I am telling previously electrical transducer, it is basically measured for the non-electrical such as temperature. I am written here. Electrical transducer. So mostly quantities to be measured are non-electrical such as temperature, pressure, displacement, humidity, fluid flow, okay, speed, etc. Okay, but these quantities cannot be measured directly. Okay, so this is a basically measurement area of the electrical transducer. So using this electrical transducer, it is basically mostly uses non-electrical quantity. That means the non-electrical means that is the temperature, that is sound, that is pressure, that is displacement, humidity, fluid flow. These are the basic non-electrical signals. You have to convert it from electrical energy to the different form. I am given one example. That means your microphone, this microphone, it is basically changes your voice signal into the electrical signals. Okay, so in this category there are different types of sensors that are available. Okay, so now what is the basic definition of the electrical transducer? So the function of converting of the non-electrical quantity into the electrical signals or in electrical purpose, it is basically called the electrical transducer. So now the definitions is note down it. What is the electrical transducer? The function of converting non-electrical quantity into electrical, 1 minute, one is accomplished by a device called the electrical transducer. Is it clear, all of you? Anyone, any doubts of this? Ask me. Don't hesitate, okay? So this is basically a definition of the electrical transducer. It is basically important purpose. So the function of converting non-electrical quantity. So what are the non-electrical quantity? Here you can see this is the basically temperature, pressure, displacement, humidity, speed, fluid flow, etc. So these are the basically non-electrical quantity which is converted into the electrical energy or electrical form by a device, that is accomplished by a device. This device, it is called the electrical transducer. Is it okay, all of you? Okay, so this electrical transducer, it is basically sensing the device which is physical or mechanical or optical purpose, then it is converted into the another form. Okay, so sometimes it is uses for the resistive, inductive, or capacitive. Okay, that means when you have to changes non-electrical quantity into the another form, it is also changes some resistance, some capacitance, sometimes it is changes the inductance. So using these changes of different of resistance, capacitance, okay, or inductance, you have to measure one by one the electrical transducer. So when you have to go the laboratory, in our measurement lab, there are different types of sensors are available. So you see one by one how it is working on now. Okay. So now another questions. Next slide. So advantage. What is the advantage of uses electrical transducer? It is basically one important question. Please note down it. Advantage of electrical transducer. So there are different properties or different area why it is selected electrical as a electrical transducer. So first of all, it is advantage, that is a friction effect. You know that friction effect is reduced to the minimum possible. To the minimum possible. Because you know that when it is uses for the mechanical transducer, this mechanical transducer, that means it is rotating. So some instrument are rotate or straight. So there are one friction effect is coming. So when you have to use this electrical transducer, this friction effect, it is basically reduced to the minimum possible. So this is the basically first advantage. Okay, is it clear? Number two, mass inertia effect. Mass inertia effect are reduced to the minimum possible. Reduced to the minimum possible. Okay, so that means when dealing with the electrical or electronic signals, okay, this inertia effect, this mass inertia effect, basically it is uses for the when electrical energy is transferred from a device. So here the electrons is flow. So this mass inertia effect, it is basically very low. That means it is negligible of the mass inertia effect. So this is the basically one advantage for the electrical transducer. Number third, very small power is required. Very small power is required. You know that? So using this electrical transducer, there are some low level of power it is required for the controlling or uses for the different electrical or electronic systems. Okay. Another one, the electrical output of this electrical transducer electrical output can be amplified to any desired level. To any desired level. Okay. So this is another one advantage. Number 5, that is uses for the microprocessor or small type of IC. That means small IC microprocessor. So this small type of chips you have to use it. That is a small size in application. So you know that IC means integrated circuit, MP means microprocessor. Okay, so using this small type of IC or integrated circuit and microprocessor, you have to design one big instrument in a small size of instrument. So using this electrical transducer, it is basically easily you have to design. Okay. Another examples, another advantage is also available. There are different types. So these are the basically main important advantage why you are uses electrical transducer. Is it clear, all of you? Please respond me. Anyone? Is it clear? Muskan, it is
Yes, sir.
clear.
Yes, sir.
Yes, sir.
Yes. Okay. Next. So everyone write your own name and roll number in the chat box. And Rahul is present. That is regular student Rahul.
Yes, sir.
So Rahul, you take a screenshot for the participant list in one page. Then after ending the class, you have to send my personal WhatsApp. This is the attendance record. And please everyone write your own name and roll number in the chat box also. This is recorded.
Mambi. Okay, sir.
Yes. Anyone any doubt or any questions? Okay. Now next questions it is, what is the basic requirements of a transducer? Okay. So next questions. One minute. My whiteboard is slightly disturbed. So next question is basic requirements of a transducer. So the main functions of a transducer, you know that it is basically changes physical energy to the another form, okay, or non-conventional energy. So there is a non-physical quantity to the another electrical forms also. So using this transducer, it is basically requirements of different pattern. That is the first one. It is ruggedness. RUGGEDNESS, ruggedness. So what is ruggedness? So it is basically capable of the withstanding any overload or some safety arrangement. It should be provided for the overload protections. So I am written here this ruggedness. It should be capable of withstand overload and some safety arrangement should be provided for overload protection. Okay, so this is the basically roughness. Number 2, linearity. 1 minute. This is the linearity. Okay, so what is the linearity? So when you have to measure the input and output purpose, any energy to convert one form to another form, it is basically symmetrical physical quantity you have to measure using this linearity. So what is linearity? Its input and output characteristics should be linear and it should be produced these characteristics in a symmetrical way. Okay, so this is the linearity. Number third, this is repeatability. Please note down this point also. This is basically very important. Repeatability. What is repeatability? That means when you have to measure any examples one by one, that is a continuous timing it is used. That means it should be reproduced some output signals when the same input signal it is applied again and again. So this is basically called the repeatability. Okay. Next, number 4. Everyone, please write your own name and roll number in the chat box because time is very limited. And Rahul will take a screenshot for the attendance purpose. And 4 is the high output signal quality. Okay. Number 4. 1 minute. That is a high. OP means output. Okay. High output signal quality. And number 5, no hysteresis. No hysteresis. And number 6 is residual deformation. Residual deformation. So these are the basic requirements for the electrical transducer. So hysteresis, that means it should not give any hysteresis losses during the measurement. Okay, so this is basically requirements. And another one, residual deformation. There should not be no deformation or removal of any input signals for a long time applications. And it is also given high output signal quality. That means when you have to use any good quality of measurement, so you have to measure particular high output it is coming. So that's why you have to use this particular uses for the transducer. Okay, so these are the basic requirements for the transducer. One is roughness, number 2 linearity, number 3 is repeatability, number 4 high output signal quality, number 5 no hysteresis, number 6 residual. Okay, is it clear all of you? Next class we have to conclude